Hello guys and dolls, welcome back to Honey Badger 3D Print and Paint. Today, we're at Formnext. So this is Formnext 2022. There are some amazing manufacturers here with loads of cool new tech and loads of fun things to look at and touch. So we are going to take a look around, do some interviews and show you some of the massively cool stuff that is coming in the next year. Hello guys and dolls, so we are with Raise 3D checking out their Pro 3 and the hyperspeed upgrade kit that they have just released. So first of all, talk to me about the Pro 3. So obviously you've got a very established ecosystem at this point. You started out with the N1, you've built up with the education machines and through the Pro 2. So what's new in the Pro 3 that people are going to get really excited about?
So essentially the E2 and the education machines were the learning step in between. So the Pro 2 was a workhorse. It really did everything it needed to do at a very stable rate, but the user friendliness wasn't quite there yet. And that's something we improved on with the E2. So we got the automated bed leveling and we got an advanced calibration procedure on the screen. And all of that has now been baked into the Pro 3 as well. So the user friendliness has been greatly improved. We've got the flexible steel plate now, we've got a mesh leveling for the print bed, and all of these sorts of things. Right.
So that flexible build plate, which I want to be clear, is very hot. It's currently burning my hand, so that's fine. Is all magnetic, all auto bed leveling, and is it true bed level? Does it actually level the left and the right?
No, it does not.
We will cut that bit out.
You have to cover it once at the beginning, so you measure it, and then you've got 9 screws that you adjust.
Right, okay, fair enough. We'll pop that back in. There we go. So let's talk about the hyperspeed upgrade kit, because this is one of the new things you've brought to the show. So this is 2 new cores that go into your machine, providing your machine has 2 cores, and then we do the accelerometer piece as well. So talk a little bit about what that accelerometer and calibration piece does for us.
There's basically 3 parts to the upgrade kit. You've got the accelerometer sensor to calibrate the own frequencies of the printhead. Then you've got the new hotends, and then you need a new filament as well, because all 3 components are important to maintain the same accuracy and reliability that we're otherwise used to from the Raise 3D printers. So essentially, before being able to start with the Hyper FFF speed upgrade, you do a calibration with the accelerometer in the left position, and essentially the printhead just rattles around and measures its own frequencies, and then these can be compensated for during acceleration later during printing. Brilliant. So you do that with the accelerometer, then you swap it out for the actual print cores, then you're good to go.
So it's a one-time deal until, well, I say that. Let's not say that again. So this is part of an ongoing bit of maintenance you do with the machine, right? So every sort of couple of months you
Every
recalibrate.
2 to 3 months you should recalibrate, just because over time some of the frequencies can change due to looser belts or something like that.
Absolutely.
So you just want to redo it.
And then obviously if you move your machine from where it is to somewhere else, you'd recalibrate then as well, because the sort of the rigidity and everything changes and all of that good stuff. Fantastic. So, I mean, what print speeds are we talking about now? Because you weren't slow before, right?
Before we were in the, I'd say, middle field with all the other printers at 50 to 80 millimeters per second roundabout. And now we can go from about 200 millimeters to 350 millimeters per second while printing. So it's actually really impressive seeing them go up.
That's nearly 5 times faster than you were going before, with no loss in quality, with no loss in surface textures or details or anything else.
I mean, that's due to the filament as well, because it has a better cooling and a better heat transfer, so the features stay just as sharp, even though we're going much faster.
Amazing. That's really cool.
So this part before took over 13 hours, now it's down to 4.
So this is something that there's been a real shift in the market in the last, I would say in the last 2 years, where originally it was about how can I print high quality parts, period. That was it. It was all about quality. Now, cheaper machines are getting higher quality, and now there seems to be a real shift towards speed. It's yes, we can all do quality parts. How do we now do them faster to improve your workflow? And it's refining and refining and refining. I mean, Raise 3D has been setting standards in the industry for a number of years, 7 of them to be precise. But you guys continue to innovate. So are there any secret things that are in the works that you're allowed to tell us about? That we're allowed to say are sort of the next things that are coming for the platform?
Not entirely certain what's in the plans for the future yet. This was our big upgrade since 1 week ago, so I think we'll look at this. And then of course we've got the other printers coming up.
Absolutely.
So the RMF 500 and the Metal Fuse both coming in 2023. So that's going to be the next chapter, is We're happy with this for the time being, of course, keeping adding more materials, making everything even better. And this right now is step 1, let's call it that.
Yep.
Before we said we were printing at level 0, which was the standard 50 to 80 millimeters.
Yep.
Now we're at level 2 with 350 millimeters per second. We want to push that all the way to 500 millimeters per second in the future.
Wow.
But
okay.
I cannot promise when that will happen.
That's fair enough. So let's take a look at the HyperFF technology that you've got going on as well over in the other part of the booth. We're back with Raise 3D. We're looking at the Forge 1. So as you can see here, we have the Forge printer, we have the little house that it sits on, and then we have the giant loft conversion. So the giant loft conversion is the material housing so that we can print metal filament. So talk to us a little bit about what this machine is actually doing, because this is exciting.
Right, so it's taking a metal filament from BASF and printing that onto a glass plate inside the printer. There's a sort of glue around the metal particles in the filament.
Yep.
And then after this part is done, it is what you call the green part. And you take that to a debinding station where the glue gets removed, essentially. Yep. Then you have a brown part, and that then needs to go into a sintering oven, at which point you've got a fully solid metal part.
Right, and that's as solid pretty much as...
It's essentially steel.
Right.
It's fully steel. This filament right now is 316L steel, and that's going to be what your actual part is going to be
which is 10 better than 350 steel. I don't know that for a fact. I don't even know that's a thing. But yeah, so obviously this is effectively, as we said before, this is effectively a modified and adapted Pro 3.
Right.
But we've still got 2 cores in this, and there's more materials that are going to be coming. That means you could actually do multi-material parts where you could have, for example, you could have steel as one part, and then you could have an aluminium as a secondary.
That's most likely going to be difficult just due to the next steps in the processing, like the sintering oven,
right?
Because of the melting temperatures of the different materials.
Okay, fair enough.
But what you could have is a support material for overhangs and stuff like that, which currently is not viable yet.
Right, but it's an ongoing and growing ecosystem that you guys are putting forwards.
And the reason this is so tall, because we get this question a lot, is because metal filament is quite stiff and it really doesn't like going around sharp corners.
Right.
So unlike with the regular Pro 3 where you can have these tubes going to the printhead, here we want the filament to stay as straight as possible no matter where the printhead moves. So that's why you've got this distance.
So does the spool hole, that doesn't move backwards and forwards or anything?
No, it
does
just stays there in the
stays where it
center.
is, but it's always so that it's got the straightest shot down, so it can pull that filament down and give the best quality finish. Oh, it does look really good. We'll show you some parts in a second. Thank you very much for your time. Catch you on the next one. Right, okay, Conrad, we're here at the Plasmics stand with the CEO of Plasmics, and we have what I hope is a slightly larger than life model and a more real model of the new Plasmics hot end, the Inno Trident. So this is your induction hot end. Tell us all about it. Everyone's seen the promotional pictures, everyone's seen it online. Talk to us about the benefits and what we get from induction heating over traditional 3Ds.
So I'm glad to be able to show it offline and in real life, because we had some questions about this. Is it even real? Yeah, the Inno Trident heats up in little time. It reaches 450 degrees. We have a stainless steel nozzle, it's actually armor grade nozzle, which can use pretty much every material you throw at it. And yeah, you can vary your temperature profiles depending on what you want to print. That's something nobody else can do because the systems are too slow usually.
So there's a huge amount of benefit going with induction, specifically and most importantly, heat creep. So heat creep is an absolute killer, especially inside of enclosed machines, where because the heat is located at the top of the nozzle, it will eventually permeate down unless you're able to keep all of the top part in this heatsink cold. When you're talking about induction heating, we really reduce that heat creep. We keep it much more localized to the melt zone, and it's not going to start permeating all the way down the machine, causing a bunch of clogs, causing a bunch of issues. I know that I've used fetus dragonflies and all sorts of things, and one of the biggest issues they have is that if that part cooling fan isn't high flow, it's just gonna cause you all sorts of mischief. alongside the Trident, we also have what's possibly the best looking printer at the show. So the best looking printer at the show is the Delta S. It's a Delta, and my God, it looks like a Swedish piece of furniture. Like, it is glorious. So tell us a little bit about the Delta S as well, Conrad, because I'm seeing a lot of real-time graphs and a lot of real-time information. So tell us a little bit about what this is showing, how it's working.
So the Delta S is basically not only a 3D printer, it's actually an integrated quality control system. We don't only trust that the filament is going to have a diameter of 1.75, but we actually measure it. And oh my, reality is that it's always oval, the filament, and at the times it's twisted on your spool, and we measure this and we adapt the extrusion factor accordingly. So we see, okay, there's more filament, so obviously we have to extrude a little less, and the other way around. Pretty
so
straightforward.
this is flow rate regulation in real time.
In real time.
With active sensors that are literally saying, yeah, just so you know, it's thick here, thin here, thick here, thin here, and it's reacting and changing the flow rate in real time. So I don't know if I can explain in words how important that is. So when we talk about some of the great printers that we've had on the channel, we'll talk about really recently the Bamboo Labs, right? The Bamboo Labs does a purge line, which it then does a LiDAR over, and it measures that flow. But that is a moment in time. That is at the beginning. We did a flow rate test. We're pretty sure this is what it is, and we're doing the best we can with the information we've got. This is in real time, reacting and changing how this printer is moving based on active sensor information. So this isn't just a moment in time, it's right now. And this is actively doing this as it's going.
Yes.
So that's astonishing.
And here you see the extrusion factor. So it's actually adapting this extrusion factor when it's, maybe it's going to take a minute, and then you see it's switching around
but
every now
you can
and then.
literally see it in real time going between 99.12 and sort of 98.75 and all of this. So when you're trying to do high quality prints, high quality filament is absolutely key. And one of the reasons for that is because lower quality filament has lower level consistency, and it messes about with your flow rate, messes about with your surface quality. What we're effectively witnessing here is a machine that you could put near enough any filament into, and it will just adapt its flow rate accordingly to whatever it is in real time.
But even more than that, because we have a camera integrated in here, which is going to take layer by layer pictures of what you're actually printing, then comparing it to your G-code, what you actually wanted to print, and analyzing the errors you have in between there. So you have what it should look like and what it actually looks like.
So then we have active AI monitoring for surface quality and imperfections.
Precisely.
That's astonishing. So I'm right in saying as well, this is closed loop stepper drivers. So this is, so again, just to very quickly recap what closed loops are. Generally when you use a stepper motor, it's dumb. You issue a command, you tell it to move 7 steps, it moves what it thinks is 7 steps, and that's it. When we're talking about closed loop stepper drivers, we're talking about a command that's issued and a command that comes back to say, yes, I have moved 7. So the idea of skipped steps, thing of the past. They can't happen, because the machine knows if it's missed a step, and it can issue another command to just simply make up the steps that are missed. So wherever you knock a tool head or you shake the printer or something like that, the active closed loop stepper motors can actually just adapt to that, and it can throw out errors and let you know that a step was missed or part of that model isn't going to work. So, okay, so what else? I mean, other than the fact that this just looks amazing, what else are we looking at?
Like a water-cooled effector and hot end, as well as an actively heated chamber, which is insulated. So we are having 80 degrees inside it's possible. So we can print up until Ultim at the moment. We have already printed peak, but this is that's not our main purpose.
Yep.
and the next generation is going to go up to 150 degrees internal chamber temperature, and then even peak should not be a problem anymore.
So we're already talking about carbon fiber, PETGs, ABSs, all the regular filaments, ASAs, and everything else. PET-Ts and sort of the beginning of engineering grade materials at that point. I mean, once we're into ASAs, even engineering.
It's 80% of the engineering.
So that's,
materials.
I mean, that's huge. So okay, so what's the price for for a Delta S? How many of my children will I have to give away? And I've got some ugly kids, so they're not gonna get a lot. So like, just bear that in mind.
So at the moment we're selling it at 7,887.
7,800. So really, your crosshairs
euros.
are Raise 3D, are Ultimakers. They're the kind of guys that you are really ripping apart with a machine like this, because the speed that you're able to produce, the materials you're able to cover, the specification, everything that you're able to pitch at, you're covering so much more of the spectrum than other competitors are in that place.
That was our intention. Exactly.
Amazing, brilliant. Right, well, a beautiful machine, a very large but beautiful hot end. We'll take some shots of the exploded design as well, so you guys can take a look at that. But thank you very much, Conrad, for taking the time.
Thank you,
It's been a
James.
pleasure. Catch you on the next video.